In this video, I'm going to be talking about multiplying and dividing integers. And when I interview students who can consistently process signs correctly when they're multiplying and dividing, they often have a process that they just can do without thinking about it. For instance, if you ask them, how much is negative 2 times negative 3, they'll just say 6. But if I ask them to describe to me how they know it's 6, well, they'll say something like, well, 2 times 3 is 6, and the signs are the same, so it's positive. They give a two-step process as the rationale for their answer. It's this two-step process that we're going to use. So again, what they do is they first treat the two numbers as positive. This is taking the absolute value of the number. And then they multiply or divide the positive numbers, they get a result, and then they go back and they look at the signs. If the signs are the same for the two numbers, then it's a positive outcome. So 2 times 3 is 6, negative 2 times negative 3, also 6. On the other hand, if the signs are different, then the outcome is negative. So here's the procedure we're going to use. Notice it's for two integers at a time. We treat both integers as positive. We find their product or their quotient. If the integers had the same sign, the product's positive. If they had different signs, the product's negative. Notice this doesn't speak to 0. 0 doesn't have a sign. So we have a second idea for 0. And that is, if you multiply two integers and one of the two or both are 0, then you can replace the product with 0. I'll run through the first one, and then there'll be some for you to try. Keep in mind that I often have problems that have given students trouble in the past. So if you find yourself making a mistake here or there, perfectly natural. I'm supposed to count the operators, discuss the order, and then simplify. Notice I have two operators. I'm multiplying twice. That's what the parentheses are telling me. Because I need to multiply left to right to follow the order of operations, I would first multiply negative 7 and 2. I'll get a product, and then I'll multiply that product to negative 2. When I multiply the first two, 7 and 2 is 14. The signs are different, therefore it's a negative 14. Next, I multiply 14 and 2 and get 28. This time the signs are the same, so I get positive 28. Here's one for you to try. Please pause the video, get an answer, and then start the video again. Now, this is an interesting problem, and the reason is that there's two ways you can do it. One way, there's two operators here, and the other way, there's only one operator here. I'm going to do the one operator approach since it might be the one you haven't seen, but then I'll also describe the two operation approach. The one operation approach sees a multiplication inside the brackets. By the grouping, that multiplication has to be done first. 1 and 5 is 5. The signs are the same, so it's going to be positive 5. Next, the opposite of positive 5 is negative 5. The second way you could have done the problem is to realize that another way of interpreting this little dash symbol here is as a factor of negative 1. That is, you see this as negative 1 times the product. You'd again start here and get 5, but then here you'd see this as negative 1 times 5, which would again give you negative 5. If you took the second approach, then you should have counted two operators. Here's the next problem. Please pause the video and work it out yourself. In this case, I have 1, 2, 3 operators. I'm going to multiply first, subtract second, and find the quotient third. 6 and 4 is 24. The signs are different, so it's negative 24. 6 minus 4 is 2. And then negative 24 divided by 2, I'll think of as 24 divided by 2. That'll give me 12. And then the signs are different, so it'll be negative 12. Here's one that often gives students some trouble. I need to count the operators first. I have a division, a multiplication, a division, a multiplication, and a division. There's also some issues where you could visualize this as -1 times this, for instance, but I'm not going to take that approach. I'm just going to treat it like it looks. So I have 1, 2, 3, 4, 5 operators. And for all three, because of the parentheses, I'm going to have to do the division first. Positive 9 divided by positive 3 is 3, and the signs are different, so this will be -3. 9 divided by 3 will be 3, and again it'll be -3. And again, 9 divided by 3 is 3. Signs are different, so it's -3. All of these are -3. Sometimes students have issues with whether this dash symbol's in the numerator, out front, or in the denominator, but in all three cases this will return -3. Now I'm going to multiply left to right. 3 times 3 is 9. Signs are the same, so it's +9. 9 times 3 is 27. Signs are different, so it's -27. Here's another. In this case, I have 1, 2, and sometimes if you want to think of this as a factor of -1, you might think of 3 operators. Again, I'm just going to consider 2 operators, and at the end, I'm going to take its opposite. By order of operations, I'm going to multiply in the numerator first. 2 times 6 is 12. Signs are the same, so it's +12. 12 divided by 4 is 3. Signs are different, so it's -3. And again, there's 2 ways you can process this. The opposite of -3 is 3, or if you want to see this as a factor of -1 times -3, that will also give you 3. And here's our last one. In this case, we have 1, 2, 3, 4, 5 operators. The 2 multiplications in the numerator, and then the subtraction will be first. This multiplication will be next, and then the division will be last. 8 and 5 is 40. The signs are the same, so it'll be +40. 2 and 15 will be 30. Signs are again the same, so it'll be +30. 40 minus 30 will be 10. 5 and 2 is 10. Signs are different. It's -10. And 10 divided by 10 is 1. Signs are different, so it'll be -1. Well, that concludes our work in this video with multiplying and dividing integers.